All right, welcome everyone, and thank you today for joining us for our technical webinar here at Panzura. Our topic today is Cloud Mirroring 101. So we are very excited to have Rich Weber here to present. Rich is President and Chief Product Officer here at Panzura, and he will be presenting today on the technology and the architecture behind cloud mirroring, as well as its implementation, configuration, and administration. So before we begin, just want to go through a couple housekeeping items. You all will be muted on the call, so please enter any questions you might have in the questions panel on your GoToWebinar control panel. We'll take time to go through your questions at the end of the webinar period, time permitting. All right, so with that said, we are ready to get started. Rich, I'm going to go ahead and hand things over to you.
All right, thank you, Nick. I really appreciate that. Thank you for joining today. Really appreciate this. We're excited about this feature. Cloud mirroring is the primary new feature in the 8.0 release. And there are a few things that we're going to go over today in this webinar. The first is going to be cloud mirroring. What is it? What does it do for you? Why do you care? Architecting a multi-cloud strategy, and that can begin with cloud mirroring, and explain what your options are there and how does it work. And then, of course, how do I monitor that cloud mirroring? So today, if you're a customer of Panzura, you've got a primary cloud. How do you monitor the secondary cloud, and what are the tools for doing that? And then we'll go over what a failure looks like, how the system behaves, how it synchronizes that data between the two clouds, what those cloud options, and then we'll look at what the finish off with what's next, how to contact support or Panzura to set up cloud mirroring, as well as some of the benefits and summary of what you get out of the feature for cloud mirroring. All right, so first, what is cloud mirroring, right? So what cloud mirroring first does is it synchronizes all of your data between two clouds or two distinct object stores. In today's Panzura before 8.0, effectively what all of the filers would do is build a global file system. And part of being able to access that data from any point in the globe through the global file system is all that data is securely aggregated and written to a single cloud provider, whether it be an on-prem private cloud or a public cloud. Cloud mirroring will actually add a secondary. And one of the reasons to do this is, though outages are rare in the public infrastructure, they do happen. They generally happen a few times every year. And even if they last only a few hours, a lot of customers, that downtime and loss of productivity can be very expensive. So what cloud mirroring will do is provide uninterrupted services even during a cloud outage. And it'll detect that outage and handle everything for you. It'll also provide total redundancy of that data between two separate and distinct object stores. So we've had many customers ask, hey, how do I back up my cloud? How do I back up the object store? Well, it's essentially durable in that there are usually at least 3 and maybe up to 6 replicas in the cloud. But if you wanted to have 2 complete distinct or 2 separate vendors to have a complete backup of that, cloud mirroring will provide that, that redundancy of data and increase the availability so that there are no interruptions to users. The failover is completely automatic to the secondary. Each of the filers will detect if an outage occurs in its primary cloud provider and automatically switch to the secondary and then switch back and synchronize them. So each filer maintains the state of every piece of data that is written to each of the clouds and will automatically sync that data as the cloud comes back up. So there's no disruption to the front-end file services if there is an outage, and that's because the data being accessed from the mounted users or application is obfuscated between the cloud and the back-end, providing absolutely no interruption. So that switch requires no manual intervention, no manual detection, and no management either by the administrators or the users in case of a failure. And what's interesting about this is the availability is effectively doubled because I now have 2 completely separate access or data repositories for the data. So it effectively doubles not only the durability, but even the availability of your cloud storage. So as I said before, when the primary cloud comes back up, because each of those filers at the endpoint where the data is acknowledged back to the users and application is written, it will automatically sync that data when it comes back up. So it eliminates the dependency on a single vendor. There are some companies out there, even in a private cloud scenario, that require a dual vendor scenario or support method. This allows me to actually write between two independent providers, locally or publicly. So an example is, I may be writing to IBM Cause, but I have a dual vendor requirement. This allows me to have an IBM Cause and say a Dell EMC ECS, or an S3 and Azure, or any other combination of that. So why would an organization want to do this? Why does it matter? Well, the first starts with the durability, right? If you go and you look at each of these providers, the advertised number of nines is quite high, 16 nines. But the dirty little secret to that is that keyword is durability. The availability may be 4 to 5 nines. The only way to increase that availability is with cloud mirroring, and it's important that that's done by the edge. So you can do the replication between, say, regions, and you can do, some of the providers will provide replication services between regions. However, the thing to understand and what's most important about that is that replication between regions is an eventual consistency. That means that it is a best effort replication. If I am writing in one location and then there is suddenly a failure, that switchover requires manual intervention. And if I switch over, because it is a best effort replication, it's possible that a failure happens in one region. I manually switch over to the secondary region and request a file that was recently created or written. It may not be there, which means you'll have effectively a loss of data or an outage of that data in that time frame, and that will cause an issue. Cloud mirroring, just like mirroring a disk on a local server, is at the edge where the writes are acknowledged. So this is acknowledged from the edge to both clouds. So this effectively doubles not only the durability SLA, but it doubles the total availability SLA. And this is true for any cloud provider, either private or public. So the feature is absolutely agnostic and allows the combination of any two object store endpoints. And I'll get into some of the details or the combinations of that a little bit later, but you can configure any two clouds, again, either public or private. Now, one of the main questions I hear a lot of customers ask is, do I need to start using cloud mirroring at the very beginning when I start as a Panzura customer? Meaning, do I need to create that cloud FS with two clouds, or can I do it later? You do not have to do it at the creation. You can add it either when you do start, and we'll give an example of how you can do that with the wizard, or you can add it after the fact, and we will actually synchronize those two clouds even after the fact. So if you're a longtime customer and you want to take advantage of cloud mirroring, and you've had one cloud for the last several years, you can add this with 8.0, and it will actually bring both of those into synchronization once configured. There's a key point in creating this feature is nobody likes to have to go into the back end and manage that replication or have to do a bunch of configuration elements. And we'll go what configuring that is, but it's really been designed so that there is as little manual intervention or configuration required. So everything automatically syncs. All of that synchronization and replication is done automatically within each of the filers from the locale, managing the transactions or journal file system transactions as they occur in each of the filer. All right, so let's get in a little bit to exactly how this works. So below you'll see a little bit of a drawing, and this is oversimplified. It doesn't matter if there is one filer or hundreds of filers, this works in exactly the same way. And that is because though all of the filers work in concert, they effectively create a cooperative mesh. And this is how you get the global read-write, the global locking method. And the drawing is oversimplified. There's also a peer-to-peer connection between the filers, but each of the filers independently is responsible for any changes made to the file system. And each of them is configured in a primary and a secondary or cloud mirror configuration. The primary cloud A, you'll see that we're writing to that filer. Each of the filers is writing to that filers, both of them in synchronization. Now, the read function that happens is when you read the file, or excuse me, from the cloud, you'll see that the read operation happens only from the primary cloud under normal operations. And there's a couple reasons for this. Ingress into the cloud is free, meaning anytime I write data, cloud providers have made this free because, well, the more data that goes into there, I want to make that as inexpensive as possible because data has gravity. Once it's there, it's probably there to stay. Pulling that data out can cost transfer information, and everything the Panzura filer does reduces the amount of reads through localized caching and deduplication, so it reduces that. Reading from both filers really just creates a race condition where I'm wasting WAN bandwidth and I'm incurring double the transfer charges. So under normal conditions, it will read from the primary, but it actually writes to both of the filers at the same time. Now, when it writes, it does what's known as a blind MD5 checksum. That means that it writes the data, and then it asks for an MD5 checksum. It's blind because it doesn't issue the result of that checksum. When it comes back with the checksum. That checksum is compared to the local checksum that's there. If they match, it can be released. Now, most of the time that data is actually cached. That just simply means that it can be evicted from the local cache if required, if space requires that. So normal conditions, I'm always reading and writing to the primary, and I'm writing to the secondary, but not reading to the secondary. In this way, every time I acknowledge data that's written to the object or cloud, I'm actually acknowledging that it's written to both. And each filer is responsible for and will maintain the state of every object written to the cloud and whether it succeeded or not. So in the case of a failure, there are a few things that'll happen. Now, failures on a read or even a write to a cloud because of latency and packet loss or noise in the network can occur irregularly or from time to time. So what the filer will do is when it starts to see consecutive failures, that means that I have either read or written a object and I get a failure, we always retry. We do this in single cloud mode. We'll retry and retry. In fact, we'll retry indefinitely until it comes back up in a single cloud mode. But in a secondary, we're going to keep track. And if we see sequential failures coming from the primary cloud, we will go into a cloud outage trigger, and it'll switch because it can no longer write to the primary cloud. It can no longer read to that. We'll switch the read operation to the secondary cloud. Now that means that I'm going to now read from the secondary cloud, and remember, every write prior was acknowledged to both of those clouds in the same way we acknowledge to a single cloud, meaning that I know the data is there. So I'm now going to read from the secondary cloud, and any additional writes are going to go only to the secondary cloud or the cloud B. Now this is going to happen independently on every filer in the cloud FS. So that means that I'm capable of detecting local or network outages over secondaries, though that's very rare, especially in a public infrastructure, because generally I'm accessing those over the internet. So I either have an outage getting to any public or secondary, which means I'm usually going to detect an outage that is localized to the provider itself. Now, that can also be even on a local object store, because I may have those between two different data centers, different types of routes that are there. So in a failure mode, first cloud has completely gone away. Second cloud has now switched effectively to the primary, meaning that I'm doing all my reads and writes. It also means that I'm diverging from consistency at this point. That's important because each filer now is going to keep track of the state of the objects that are written, and that state is localized, but it's also redundantly recorded into the cloud object store. And the reason that's important is because if I were to have a catastrophic failure at any one of those filers, it's important that there is no state that is localized that can be lost so that I can't bring those back into consistency. So the consistency or state information is actually maintained locally into the filer, but it's also maintained into the cloud. So in a failure mode, I've switched over. In a cloud recovery, and what that means by a cloud recovery is the filer will detect when the primary cloud becomes available again. As soon as it detects that the primary cloud has become available, it may go from a down state to an up state, but I no longer have data consistency between those two clouds. And that's because during the primary outage, the secondary took writes that didn't occur on the primary cloud. So the first mode that happens is I continue reading and writing from the secondary, but as soon as it went up, I started writing to both again. So that means the moment it came up, I'm writing in parallel. So that means from that point forward, I'm synchronizing that data, but it's also going to go back. And remember that each filer is keeping track of the state or the journal transactions that happen in the file system that were unique to that location, and it will synchronize the data. Now, in most outages, that data is actually localized, meaning it doesn't require to read that data from the secondary and then write it to the primary. However, if I even had a long-lasted outage that went for days that moved past the localized cache, it will read the data from the secondary and sync it to the primary. In that state, it's bringing them to a consistency state that is equal between A and B. Once it comes to a consistent state, it will switch over. Think of this as no different than if I had done disk mirroring in a local server, and you'll see that it actually resilvers that secondary disk just the way it would be if I inserted a new disk, configured it for cloud mirroring, for disk mirroring. It's going to resilver those disks. Everything about that occurs the very same way in the cloud. Just think of those as very long, distant connected disks, and everything happens automatic. So when I get to a full recovery state and everything goes back to normal, you'll see that it switches from sync and it actually switches all the way back to the primary on the next slide. So back to normal state, you'll see now the only thing that has changed is each of the filers have gone through its consistency list and brought each of the cloud filers back to a fully consistent state. And the read switches from the secondary back to the primary, and we're back to the normal mode of operations, or back to the original configuration. No human intervention was required, no administrative was required. There will be traps and notifications both in system as well as through SNMP or email if you have those configured as well. And we'll go through some of that in just a moment. So how do you architect for multi-cloud storage? Well, cloud mirroring is agnostic, meaning that none of the users know that there's a secondary cloud. It's completely non-disruptive to any mounted services that are provided by each of the filers. So what are the configuration options you have in terms of cloud mirroring? It is quite flexible. That means that I can replicate between two on-premise object stores or between an on-premise object store and a public object store. And some of this is very useful because we have some customers that are starting off in a fully private state, but have plans to migrate or move to a public service provider or public object store. Mirroring between those two gets you prepared. That means that my data is going to be both available on-prem or public. It also means that if I had a catastrophic data center failure where my localized on-premise object store was completely wiped out, all of my data is in a secondary public service, and that can be switched over with absolutely no disruption or even into the cloud. It can also bring you between two independent public providers like Amazon S3 and Azure Blob Storage. Again, advantages in that if I have a wholesale outage on one provider, I will not have any disruption to my mounted services on the front end because it'll fail over to a completely independent public provider. There are also advantages in terms of replicating between two regions in the same cloud provider. And you'll see some examples of that, like an LRS in Azure versus a GRS, which is a geo-replication. Same thing with geo-replications that you may see in Google, or replication between regions inside of the same public provider. The main point to remember, or why you might do this, is because those replications are generally eventually consistent, meaning that if I had a failure, I could fail over and some of my data won't be there. They all also require manual intervention, whereas cloud mirroring at the edge from Panzura requires no interventions. It also has some advantages. If I really just wanted to have a backup, I can back up that data between tiers, meaning I can use, say, an Amazon S3 standard as my primary and a Google cold line for a really inexpensive replica if I wanted all that data replicated. The failure mode will still work, will replicate over even between the lower tier. The only thing that we will say for best practices is always replicate with a millisecond or sub-millisecond response. That means any responsive tier that makes a request and responds back immediately. Basically, that means nothing like Glacier that has minutes or hours between a request. So always replicate between performant clouds, though they can be lower cost tiers. With this feature, it ensures that you maintain control of your data. You're not locked into a single vendor, and you're not exposed to a single vendor's exposure model or cost model. It means I can switch between them. And the cost of that object store has been rapidly decreasing over the years, and most of them, even at their most expensive, are just over 2 cents and well below a single cent for lower cost tiers. So implementing cloud mirroring, we'll go through some examples that are here and what you will need, but it starts off with you'll need to be running 8.0 or later. Specifically, if you're going to do this, we'd recommend going to 8.0.08 or higher. It's the latest patch that's coming out next week. So ensure that you work with support and you have the latest version of 8.0, or if you're upgrading, go through the upgrading process and then you can implement cloud mirroring. The first thing that it's going to require is a license for the filers. Now, to be clear, this is a configuration license. It's not. You're not going to have to go through sales. Just go through support to get that. And you're not going to have to configure that cloud mirroring on every filer. So if you've got 100 or hundreds of filers, you don't have to do this configuration on each individual filer. It will utilize a feature that we take advantage of in 8.0, which is a group license. That means I'm going to configure it in the master, and the master is going to push that license to all of the filers. So it's fairly easy to do that configuration, and it's fully controlled and pushed from the filers. Once it's pushed, that configuration is independent, meaning it will check back to see if there are changes, but if your master went down, it's not going to impact anything in terms of communications from that. You also need the credentials to set up your primary cloud provider. If you're a new customer, it'll already be configured if you've already configured that. And you'll, of course, need the credentials to get to the secondary cloud filer. There's a few simple configuration elements that are there. We'll show that example in just a moment. All right, so if you're setting up a filer for the first time, the first thing that's going to happen is you're going to get walked through the implementation wizard or the installation wizard. The wizard is going to walk you through several things like what's my IP address, what's my DNS, my NTP servers, and at the end it's going to ask you to configure the cloud storage provider. Now you'll see there's a simple switch that when you go through this, and most of the time you'll be working with support or professional services, they'll walk you through this, but we'll show exactly what's done. Setting that switch to enable cloud mirroring on a new installation is going to enable not only the primary cloud provider, but you'll see once you enable that, a secondary cloud provider comes in. Now, in this case, you can pull from the pull down, and if you click on that, you'll see a list of all the cloud providers that we support. You would select one of those. This example is going to select Amazon. And as soon as you select that, the fields that are unique to that provider will show up. And like I said, there's about a few, 3 or 4 elements, meaning that I have to say what's my endpoint, what's my access key, my secret key, and then of course the bucket, and then the path. And the path is really just think of that as the virtual folder that it's stored into. And then of course the size that you're going to be measuring to that in the port. Once you do that for the primary, the wizard's going to walk you to do exactly the same thing for the secondary. This example is collecting Azure. Again, I'm going to put in my specific credentials for that cloud. And once I do that, I'll click next. And then the filer is going to do everything on its own. As soon as I hit next, it's going to set up that virtual file path. It's going to write the initial information to that, and it's going to immediately move into cloud mirroring mode right off the kickup. On a secondary one, you'll add a license. If you already had an existing one, do the same exact fields. Support will walk you doing through a group license, and that will push it to all the filers. So the similar setup for an existing customer, except you're going to do that in the license manager as opposed to the wizard, but exactly the same fields will be configured and then pushed. So the next question is, how do I monitor my clouds? As soon as you add that secondary license, that license, when you hear from support, they'll refer to it as a CMP. Your primary cloud is called a CSP, or a cloud service provider, and a CMP just simply stands for a cloud mirroring provider. And that's because we have a distinct primary and a distinct secondary, a CSP versus a CMP. As soon as the CMP license exists and it's successfully acknowledged and written to the cloud, and that's been confirmed every time you configure a cloud, it does a test, a self-test to ensure that it can have access, that it can write, it can read that data. As soon as you do that, your dashboard will change. Normally, your dashboard is going to show your client to filer, filer to client. You can gray those out by clicking them in the key. You can see in this example they're grayed out. And then the cloud is specifically from the cloud to from the cloud to the filer, and the filer to the cloud. When you add a secondary, you then changes from a primary cloud to a filer, and a filer to a primary cloud, and a secondary cloud to the filer, and filer to the secondary cloud. Those are charted below, and on the right shows you the total amount of data throughput for the time range selected in the slider below. Anytime you hover your mouse over that illustration, or excuse me, that graph, you'll get the details for that point in time in terms of the throughput for each of those clouds. So on the dashboard, automatically will change. You can see the throughput going to each of the clouds, and they may be varying because they may be a little bit different, especially if you're synchronizing data, and I'll show what that looks like in just a moment. The other portions in the dashboard you'll see is in the filer status, there's a new section to the right. And that's the section you see in the green where it says cloud mirroring status, master snapshot status, and new cloud resilvering status. Those statuses will really be important if you're an existing customer or you're a new customer that started off with one cloud and you added a secondary cloud. Anytime the cloud is resilvering, you're going to see that that is not going to say synced, and you're going to see that it's resilvering in a percentage process, that it's moving through that. When it comes up to sync, it'll let you know and look exactly like this, that everything is done on the resilvering and the status for everything is synchronized. The normal status to the left is equivalent to what's there. There's one other section that you'll see in terms of the overall status for the cloud. You'll see this on the right-hand side of the dashboard, and that shows what the cloud status is. Right, so this is going to show the connected status, and that is going to be explicit in that green section, right? You see primary cloud is up, secondary cloud is up. That will show you the health or the active status of each of the clouds. Now you're going to see a failure in access count. It's going to keep track of each of those. Don't be alarmed if you see failures. They do occur in a public infrastructure. The filer always, even in a single cloud, will automatically retry if it can't get the data, either if it's a write or if it's a read, and it'll retry doing that data. In a failure mode, that is detected that it's going to see several sequential failures in a time frame that I'm trying the same object. Now be mindful that we actually write and read objects in parallel. So we may be doing that with anywhere from tens to over 100 parallel connections running to that cloud. So you can see a lot of read attempts and write attempts. What's important is we see that same object fail, 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 fail in a time period. It will then change from an up status to a down status, and you'll see that right in the dashboard. And on the next slide, you'll see that there are failure modes we'll show that in a future slide. A failure mode that will indicate that a cloud status has changed, and there will actually be an SNMP trap that is sent. There's an email notification, as well as it'll come up in the notification center inside of the web UI. So the other one is, how do I monitor? Right. So if you're familiar with how to monitor or do some of the diagnostics tests with your primary cloud, if you're an existing customer, you can go into the maintenance section. You get there from the primary screen inside of the web UI, go to maintenance, then go to diagnostic tools. Under the diagnostic tools, that command type has a pull down. Go to Cloud Connect Test. You don't need any parameters, just hit run. And it's going to go, depending upon the provider that you have configured, it's going to do a bunch of connectivity tests. So it's going to ensure that it can connect to that endpoint. It's going to do a quick test of a read of the buckets and come back with either a fail or success status. For a secondary cloud, it's going to happen. It's going to append that to the normal test, and it's going to happen all automatically. The secondary cloud will be tested as well, and you'll see the output of success on connectivity for that as well. So you don't have to do anything new. It's exactly the same diagnostic that you did for primary cloud. Just as this here, when you do that normal diagnostics or Cloud Connect test, it's going to additionally test the cloud mirroring provider or the secondary cloud. Same thing if you want to do a upload or write test. Same exact diagnostics that you did for a single cloud. I'm going to go to that command type. I'm going to pull that down. The parameters are basically what's the size of the object that I want to do a test. This example is doing a 1 megabyte object. You can change that to anything you like, and the number of times to do a test. In this parameter, it says 5, so it's going to write 5 1 meg objects to the primary cloud. It's going to write them. It's going to see that it's got an acknowledgement of that write. Again, that's going to be through the blind MD5. It's going to measure that it went through and what the time that it took to write each of those objects. Then it's going to in turn download those. So it's going to write a piece of data. and it's going to read a piece of data, and you're going to see that you should have success on each one of those. It is then going to follow the CSP and go to the CMP doing exactly the same test. So no change in the diagnostics that you do for a primary. It's just going to add, as soon as you're in a cloud mirroring configuration, it's going to automatically test for both and show you the output test of that. That should mirror the state that you see in the dashboard, right? So the first thing that you may see if you call support is they'll have you run these tests, see that everything is successful or not, and it should show you explicitly where you're having a problem. Same thing if you're a Vizion.ai customer, and you'll notice that there is a tool called Freedom Pulse. Inside of Freedom Pulse, if you'll see that on the lower side under monitoring, click on Freedom Pulse, select the Cloud FS that you're monitoring, and then you'll see there's a connection for cloud. Click on the cloud, and you will see the metrics for the cloud throughput, the aggregate throughput, and some of the monitoring for all filers. I can highlight the filer throughput by each of those filers that are selected. If I float over them, it will effectively bring the focus in for them, and you can see all of the filers and the status of all the filers at once, as opposed to looking at a single filer context. If you're usually doing diagnostics, you'll do the diagnostics on an individual filer, but the Vizion.ai allows you to manage and see your entire Cloud FS all at one time. So think of that as a single pane of glass, reviewing multiple filers, both historically and in real time. All right, so if there's an outage, and I said we'd get into a little bit of this, so if an outage actually occurs, meaning that a cloud state has moved from an up to a down state, exactly what happens into the system. The next slides will show some of that. So as soon as I hit a down state, the dashboard will show that it's gone to a down state. The primary has gone to down, the secondary is still up. There's no disruption to any of the mounted file services that are there. If you switch there, you'll see the next thing that's going to happen is in the notification center, you'll see the alerts, right? That there was a trap. You'll see that in 1011, trap name, it'll come over that. That will queue up in the alerts in the notification center of the UI. If you have notification services configured into the filer, either SNMP or email, those same alerts that show up in the notification center will be sent either through SNMP or email, or both if each of them are coming from that. And it will show the events anytime a state changes for the CSP or the CMP. So that's your notification. However, as I said before, there is no manual intervention required. This is informational, of course, unless you have an outage in two clouds at the same time, which the behavior would reflect an outage as you had in a single at that point because there's no cloud available. Again, if you did get a notification that's on there, generally the first thing that we would suggest that you did is go to the diagnostics, confirm that you in fact cannot access the filer. You would here see that I had an upload test in on the CSP that failed. You see that in the output here, tries to download that, does a fail, but you see that the CMP succeeded. So services continue, however, you're in a failed state. If that outage is because of the service being provided or the public service provider, there's really nothing to do but wait. The filer will handle it, detect when it comes back up, and it will go through that synchronization process and flip back accordingly when the services become back online and back available. So recovery, primary cloud comes back up. As I said, all of this will be automatic. You'll see that the primary state goes from up to down. If I have to do any synchronization, you'll see the synchronization status change on the recovery. Again, there's nothing to do here. It is informational. The main thing to do is see that that up state had gone up. And if I run those same diagnostics again, you'll see that I get both a success for the primary as well as the secondary. You can switch to the next slide. So let's talk about some of the benefits that you get in terms of doing cloud mirroring. And some of this will be a little bit repetitive, but in the summary, let's just be sure you understand exactly why you would do that. But the first thing you're going to do is to double your availability service level agreement that you get from that provider. Now that's going to be true if you're using a public service, or even if you're using a localized private cloud, you're going to double that availability because effectively I have two independent data sources or data repositories in which the global file system depends upon. They're also going to double that durability as well, because I have the durability spread between two filers. That's going to protect you against outages. It's also going to protect you against the human factor. So best practices, generally, we're going to say do not use credentials that you use every day in your cloud. Those should be unique to the Panzura filer. And if you're using cloud mirroring and you want to protect either against the human error of deleting a bucket, and there are ways to recover that with public provider, because most things like a delete in an object ecosystem, an object store ecosystem, those deletes actually aren't immediate and can be recovered, and that has happened. However, if you have a dual cloud, they should each have independent credentials or different users that use them. And if, God forbid, somebody actually did that intentionally, they would only have access to wipe out one bucket. You'd now have still all of your data in a secondary bucket. It would automatically switch over. So even if there was malicious activity, you're protected from the human factor, you're protected from a cloud outage, and you have absolute total protection against that. You've optimized your data across multiple storage drives, and if you have, and many do, have a dual vendor requirement or want to avoid vendor lock-in, this allows you to actually have two independent vendors providing your data aggregation. So you now effectively have two data repositories. And the other advantage is if I want to take advantage or migrate or get ready to do a migration, and even in this feature, we'll have some things that are automated for that, contact professional services and we'll finish that automation, but it preps you for that automation from the edge, meaning that if I wanted to migrate from Amazon to Azure or Azure to Google, or even from an on-prem object store to a public provider's object store, that cloud mirroring will effectively bring that data automatically into sync for you. So it gets you ready for a migration that is seamless. That means that I can migrate between providers with zero downtime in terms of the front end or mounted file services, whether it be for SMB or NFS. So huge advantages to using the cloud mirroring. So what's next? Right, so if you've got information, you want to see a demo, you'll see a URL to request the demo there. I think that it might have been put in the chat comments as well, but hit that URL, you can copy it out of that, go there, make a request, and we'll set up a live demo for you to see not only the latest in terms of 8.0, the features that are in 8.0, but you can demo the cloud mirroring function live for you as well. If you're new to Panzura or you're interested in Panzura, send an email to sales@panzura.com and somebody will certainly contact you immediately. So forgive me, I know that's asking a lot for somebody to spend time on a webinar and go through that, so tried to make this as quickly as possible, and we certainly wanted to leave some time for questions for anybody that has questions that's out there. So Nick, I'll turn it back over to you to field the questions, and happy to answer anything that any questions the field might have out there.
All right, perfect. Thank you so much, Rich. Yeah, so we do now have time to ask and answer a few questions that were posted. So the first question that's come in is that of cost. What does it cost? What is the expense for implementing cloud mirroring into your environment?
I'm sorry, I should have put a little more focus on that. I did lightly touch on it to begin with. From Panzura, there's no extra cost. So if you have a current subscription to the Panzura Cloud FS or the Panzura Freedom Filers, or a active support license, support contract, 8.0 is free to you, and the feature for cloud mirroring is also free to you. We don't charge anything extra for cloud mirroring. That said, be mindful that you're going to store in two different places. If you're storing at two different providers or even two different regions, the provider will charge you for that, or if it's a local object store, it's going to take the space to double it. So they're going to charge you for the space consumed. We aren't going to take double the read requests or the WAN requirements from reading that, so you won't incur network transfer times, but you will incur that. However, the competition and the price at which that is happening has become so low that the request for cloud mirroring really came on pretty strong, which is why we had that feature. But a lot of people are absolutely looking for replication. So no cost from Panzura. The cost to store the data from your provider will certainly be incurred, but no transfers.
Cool. Thanks, Rich. Okay, so next is a couple migration related questions that came in. So I'm going to kind of group them together. kind of the first migration scenario is how easy or possible is it to use this to migrate from one cloud provider to another?
So I want to be very specific here. So right now, you can do this today, even in 7x, through connecting in with professional services, and they'll write out a scope of work, and they can do the migrate, taking advantage of some of the technology that we use for cloud mirroring, but before it was productized, and they'll do that replication behind the scenes. The difference is that required replication services that were either done behind or done that was monitored very closely by support. Cloud mirroring will allow you to bring both of those providers into sync. So if you configure the CMP, it will bring them into sync for you, and it's going to happen automatically. It doesn't require any professional services to pay attention to that. However, we will have a productized switch over to where you can do that yourself. But to begin with right now, once you contact support, we'll do a scope of work. It does need some support intervention to switch a CMP to a CSP. Okay, today you can't switch a CMP to a CSP or detect that as a configuration change that requires some interruption. However, you don't have to go through the replication services. The replication of the mirroring will happen all for you, then contact support and we'll do the cutover and the switch for you. So a lot less work, a lot less professional services, and then in a future release, once everything's fully tested, and we've gone through this multiple times, we'll allow for that switch over to change a CMP to a CSP, but you can't do that currently. You will need to contact support to do that, but all of the replication will happen automatically as part of the cloud mirroring.
Okay, so next question is a little bit of a follow-up case. It's a similar question, can this be used to switch between cloud providers? But the case is you've already implemented cloud mirroring. Cloud A is your primary, cloud B is your secondary cloud. And the question is, how can we drop cloud provider A and add cloud provider C to do a cloud mirroring that way? So you've already had cloud mirroring and you're switching the primary provider.
Yes, you'll need to contact support for that, and that's because changing the distinction from a CMP to a CSP requires some intervention that isn't productized yet. So today you would set up the normal cloud mirroring, you would bring them both into sync. Support could then switch that CMP to a CSP, and that has to be done with some licensing in the background. Once that happens, you'll go to a single cloud provider mode, meaning the CMP now became your CSP, and there is no CMP to begin with, at which point none of the Panzura is going to delete data on that secondary cloud. That's up to you to kill that bucket independently, and that's because we don't ever want to start a mass deletion process. After you've moved from a dual cloud mirror where you migrated, you switched your CMP to a CMP, now you can add that third one, right? So now I go from a single to a cloud mirroring back to a single where I switch my CMP to a CSP. Then I'm going to now add my CMP or that third option, and then the system will automatically bring them into sync. Once you do that, you don't need support, you don't need anything happen. That will happen all automatically. And then you'll see that I go to an upstate on my CMP, which is now my primary. My secondary became my primary, and my new cloud became my new cloud mirroring. So yes, you can go through that. Just make sure that when you switch your secondary to the primary, you contact support, like I said in the first question. But yes, you can absolutely do that.
Okay, so the next question is one related to synchronization. So the question here is, if you begin with a single cloud and you add cloud mirroring after the fact, and let's say you have 100 terabytes of data in your Cloud FS, and then you add a second cloud, does that data need to be downloaded and then uploaded through a filer, or does it transfer directly cloud to cloud?
So excellent question. So 100 terabytes obviously is going to be larger than most customers. I think we have some that actually have quite a large, but certainly that would be abnormal, larger than you have in your local cache space. So that means that no local filer has the entire data set sitting in its localized cache. So if I add that, it's 100 terabytes, and it wouldn't matter if it was a petabyte. Yes, it will absolutely read the data from the primary and then write it to the secondary. So it's doing a replication, not unlike what you would see if I did that with the provider. It's going to have to replicate from A to B. It's going to read the object and it's going to write the object. The difference is those are already encrypted, they're already deduplicated, so there's no manipulation of the objects. It will do a checksum and validate that everything moved. There was no bit corruption, no data corruption, and again, it will start that state management of every object that exists there. Another important one here, if it's in there that I didn't see or didn't show in the examples, is in 8.0, we've added a secondary bandwidth manager. And this is important for existing customers that have large data sets and they're adding a secondary cloud, because I am going to read from the primary cloud provider and then write to the secondary. I want to ensure that I don't flood the WAN connection, right? Whether that be an MPLS or an internet connection, which means I can independently set up a bandwidth manager for my normal traffic, and then I can set up a bandwidth manager effectively for my cloud mirroring synchronization. Now, why would I want to do that? Well, because during my normal working hours, maybe I want to cut that synchronization activity way back so that I don't consume the bandwidth, because the Panzura filers are quite capable of consuming all the bandwidth that you give it. I can cut that back during working hours and then allow the synchronization full bandwidth in the evenings or weekends or whatever time is appropriate, or I can just split it, say 50-50 moving through there. So you have an independent bandwidth manager that will govern the traffic and not overrun your WAN while it's doing the synchronization. And that will move along at whatever bandwidth you have until it's finished. And you'll see that at the dashboard, that right-hand side that says that cloud mirroring resilvering process will show you where it's at in terms of percentage of complete and tell you when it's completely done.
Okay. So the next question is, based on going back to the discussion of during cloud recovery, the fact that the filers maintain the right states and that allows for resynchronization. And I think it's harking back to that discussion. So the question is, if the local filers are able to track the state of the open and locked files and sync to the cloud, does this take the place of for the need of a high availability filer?
No. So let me explain why. The locking state is independent from the cloud mirroring, right? So remember, in locking and propagation of metadata happens in two modes, right? So there is a hub and spoke methodology, and that happens asynchronously every 60 seconds, where I'm posting journaled transactions from each change that are there. There's also a peer-to-peer connection that does real-time lockoffs, as well as moving data that may not have made it to the object store. Again, keeping track of that state that's there. That is, think of that as a front-end service independent of the back-end, though it is using the object store to do that. Even though synchronization snapshots and metadata changes, those happen to occur on both clouds, but that doesn't disrupt that service. An HA filer serves a couple purposes. One, a HA local deployment ensures equal and consistent performance at a system level failure. That means if my filer fails, or if I'm running in a VM, my host hypervisor fails, or I have some catastrophic equipment failure, that local HA takes over for that failed system and provides equal and equivalent mounted services. That is regardless of the backend object store. The backend object store needs to be available because it's providing data that's there. So that doesn't change the scenario for the HA local. And an HA global is providing catastrophic location failures, right? So if I have a whole location or regional go out, a global HA filer can take over for n number of filers at a specific locale. And it either allows people to mount to that one remotely in a different location, or it preserves the locking services for that location on the case of a takeover. So no, cloud mirroring does not eliminate the need for HA, because they're two distinct and separate operations. Think of them as front-end mounted services and back-end data aggregation, security and consistency. Good question though.
Okay, so I think we have just a couple more questions here. The next one is, could you expand on protecting data from inside malicious deletion? How is the admin access to both clouds separated, and how does mirroring handle data maliciously deleted in one location but not the other?
So this would be a best practices. So best practices is if in generally even a single cloud mode, don't use the same access key and secret key that you would for all of your other cloud functions. Meaning, if I've got 50 developers that are doing things independent in the cloud, whether it be Amazon, Azure, or whatever, don't use the same access key that users are using. Create an independent one specifically for that process, meaning that no human is using that. Now, keep that locked away, whether vaulted or whatever, so that you have that, but it's independent. That just means that I don't have overlapping privileges to gain access to that particular bucket or that virtual path. Doing a secondary, best practices would implement that don't have the same administrator that had access to the primary, have a second person or a second person's using a separate credentials to the secondary one, so that the same person doesn't have access to both clouds. Now that isn't always possible, especially with smaller organizations. However, if you do, that means that you don't have the same human with the same access to both data repositories or both buckets, meaning that I don't have the logins to wipe out both buckets. I have the logins to wipe out one. And if I did wipe out one, well, cloud mirroring is going to take over. It's going to switch over and that entire data is there. And guess what? It's going to bring that back into sync as well. So because you can eliminate the access to both, you can eliminate that human potential for maliciously deleting data. Now, that said, if it were to happen, object stores do not do wipes or immediate deletes. There are ways of recovering that. That has happened with customers before, working with that provider. Even if it's a local object store, that is a metadata operation to delete. It is recoverable. Time is of the essence, because time garbage collection will happen. It will do that. So there are paths to recover afterwards. They are not guaranteed, however. So cloud mirroring gives you sort of that belt and suspenders type of protection against that malicious activity. But it will be dependent on best practices. You give one person the keys to the kingdom, then, well, you're giving them the authorization to do catastrophic configuration changes.
Okay, so one more question. I think this was somewhat answered already, but one more question of clarification is, when you do implement a secondary cloud, what are the anticipated effects on your network in terms of egress charges as well as cache churn on the filers?
Yeah, so anytime you do a replication, you're going to read from a target, or excuse me, a source, and write to a target. Whether you do that on the back end or at the edge from cloud mirroring, there is going to be egress charges, because every time you read, it's going to do that. Now, we're going to eliminate that as much as possible, because you're not reading at a fully hydrated rate. It's compressed and deduplicated, but you will get egress charges for that. What you will on the WAN implementation, I did talk about this a little bit, and that's that secondary bandwidth manager. You will want to configure that, or like I said, a Panzura will do is it will consume as much bandwidth as you get it, and yeah, that could flood your normal either internet connection or MPLS connection while it's bringing those into sync. So be mindful, configure that secondary bandwidth manager to be cognizant of activity during normal working business hours for that locale. You can do an independent bandwidth manager for each locale or each node in the global cloud FS. So yeah, you can set the policy of how much bandwidth to consume with the bandwidth manager. And yeah, do be mindful if you're using a public provider, there are egress charges or egress charges for anything coming out, but you're going to get that in a eventual consistency or best effort replication that's happening in the back end, or a service that does that. Regardless, you won't get that in some providers for the in-cloud providers because it's running across their backbone. But anytime you're moving to a hybrid or an on-prem filer back, you will certainly see some of that.
Okay, so just I think the very last question I see here is just one last point of clarification is, when you implement a secondary cloud, can both your primary and secondary just be two different buckets in the same cloud provider?
They can. In fact, they can be the same bucket in two virtual paths. Just be mindful, that you're restricting some of your protection that's there. It's a very valid use case to have two different buckets between the two providers, just so you have bucket redundancy. And if you were to do that, I would advise that if you're going to set up a separate bucket, that you'd set it up in a separate region as well. Else, if you do two buckets in the same region and there's a regional outage, well, you went through all the effort, you did the replication, but yet you didn't give yourself regional protection of an outage. So if you are going to do that and do it between the same provider, very valid use case. And that's because it's not eventual, it's consistent, immediate consistency. So if there is a failure, you get protection about it. But if you're going to do it, make sure you do it between two regions so you protect yourself against a regional outage.
All right, so thank you, Rich. I think that is all the questions that have come through today. So I think with that said, thank you everyone for attending this technical webinar, and thank you, Rich, especially for presenting the content. So this webinar has been recorded, so keep an eye out on the link in your email for the recording. We will email it out to you over the next couple days up to the next coming week. So that brings us to the end of our cloud mirroring webinar today. I hope you all have a great rest of your day, and enjoy the rest of your day. Bye-bye.
Thank you.